Hello, good morning. My name is Shritesh Vasal and my teammates are Tejas Saraf and Vaishnav Bhujbal. I'm here to present our project OpusAI, a tool we have been building for retinal fundus imaging. The bottleneck is pretty simple. There's a massive volume of images to review. Not enough specialists have time to keep up, and strict expectations around keeping patient data secure. At the same time, just getting a single AI answer isn't that helpful. Clinicians want context, something structured, something they can actually follow. So that's what Opus AI is, a system that takes one image and turns it into a step-by-step layered report, and it can run locally so the data stays in your hands. Our goal isn't to replace doctors, it's to save time and reduce the mental load, especially for repetitive screening tasks. We are trying to do three things: give clinicians a consistent first pass on fundus images, respect real world constraints like privacy and latency by supporting local deployment, and most importantly, make the system understandable. Not one black box, but a series of steps you can actually see. From a clinician's point of view, the workflow is simple. You upload an image, ask question like any signs of diabetic retinopathy, and the system walks you through what it sees. You get a timeline of outputs, not just final answer. That helps in three ways. It's faster, you get a draft before diving in. It's consistent, every case goes through the same steps. And it's transparent, you can agree or disagree with individual parts. We see this as a decision support, not as a diagnosis. We use majorly 4 open source models of Gemma family that are used for fine tuning. First, the PaliGemma vision language model using the LoRa. Moving on to the tech part, we made a deliberate decision to stay focused. We are working specifically with color fundus photography, the kind used in diabetic retinopathy screening, glaucoma checks, and routine optic disc and macula exams. Instead of relying on one big model, we built this as a pipeline. A lightweight model starts by describing what's in the image. From there, a routing step decides which tools are actually needed. Then a specialized vision model looks at a retina specific features, followed by a medical model that structures the findings. Finally, everything gets combined into clear, readable summary. So rather than a magic answer, you get a process you can actually follow from image to report. On the technical side, this is backed by fast API service with a React frontend. You send a single request and the results stream back live, so you can watch each stage complete in real time. We also try to match how real deployments work. Lighter models run locally, and a lot of real work is in the glue. Handling structure, dealing with the small hardware cogs that come up in practice. So as we can see, the model is thinking in MedGemma 4B, the diagnosis system. In the next part, it summarizes and gives us the exact summary for the question that we have been asked. How severe the diabetic retinopathy in this image, in this particular image that we uploaded. So the summary is based on that particular image. So the business point of view is that isn't just for hospitals, it's also relevant for screening programs, teleretina providers, device manufacturers, and research teams. The core pitch is very simple. Retinal AI you can run locally with full visibility. So what's next is, it is very straightforward for the future scope. We have a proper evaluation, we'll do a proper evaluation on labeled datasets, better uncertainty handling, integration with clinical systems, and easier deployment for hospital IT teams. And just to be clear, this is a research prototype and not a replacement for clinical judgment or regulatory approved tools. Thank you.